Hello friends, hi Dr. Mohan Verma from Department of Applied Physics, Sri Sankaracharya Technical Campus, Jinwani Bhilai. Welcome you all in this lecture number 10.6. This is the part of the series CSV2 Physics, Learn with me. And the title of today's lecture is the Gaseous Laser. And in this gaseous laser, I am taking helium neon laser as an example. Outlines of the lectures, the objectives and prerequisite, different types of lasers, helium neon laser and an introduction, then the basic components of helium neon laser, then detailed structure, working principle by using 4-level system, and helium neon laser, its limitations and applications, and finally the summary. Objectives of this lecture to discuss the construction and working principle of helium neon laser along with some important applications, and the prerequisite for this lecture, the same as previous lectures. I just expect from my students that they should have the knowledge of fundamental mechanism of laser, those three types of transitions, and some fundamental terms related to quantum theory of materials transition, and the 4-level pumping scheme, because the mechanism of this based on this, and the basic components of laser. So different types of lasers. These are the detailed classification of lasers. Solid-state lasers are further classified into two parts, ruby laser and Diag laser. And in the gaseous lasers, we have two major parts. One is helium neon laser and second one is carbon dioxide laser. So here the helium neon laser is being explained. And then third is the semiconducting laser, in which the gallium arsenide and gallium phosphorus arsenide is considered. So the introduction, a gas laser is a type of laser in which the mixture of gas is used as the active medium or laser medium. Gas lasers are the most widely used lasers. Gas lasers range from the low power helium neon lasers to the very high power carbon dioxide laser. These are two major kinds of this gaseous laser. Helium neon laser is a type of gas laser in which the mixture of helium and neon gas is used and as a GaN medium, that active medium. That helium neon laser was the first continuous wave laser. This is the first continuous wave laser were constructed. It was built in 1961 by Alizon, Bennett and Harriot at the Bell Telephone Laboratories. This is the most common and inexpensive gas laser. The helium neon laser is usually constructed to operate in the red range at the wavelength of 6328 angstrom. This can also be constructed to produce laser action in green, that 5435 angstrom, and in the infrared region 15,000 to 30 angstrom. And also one can get some monochromatic light source of 6000 angstrom also by a spontaneous process at different energy levels. So the basic components of helium neon laser. In this laser, the active centers, that neon, it is used as an active center. Active medium, helium atoms are active medium. Pumping techniques, generally in this type of laser, in the gaseous laser, electric arc method is used as a pumping technique. Optical cavity, obviously this is the fiber period resonator, usually used in a different type of lasers. And pumping scheme, this is the 4-level pumping system. The structure is very simple. This is a simple glass tube, and this glass tube may be different shape and sizes depending on its application. And this glass tube is filled with the mixture of that active medium and active centers, that is helium and neon in the ratio of 10:1. And for electric arc, means for pumping process, two electrodes are used, and this is anode and this is anode and this is cathode, and high voltage is applied in between. And for the fiber period resonator, there is one glass plate here, that polished glass plate, which is 90% reflective, and this is 100% reflective glass plates. And obviously this is the structure of fiber period resonator, and that laser of 6328 angstrom, the general wavelength of this laser come out from this side, that partial polished side. Structure, this is the 4-level system. So As far as the mechanism is concerned, when high potential is applied in between this electrode and cathode, that helium and neon get ionized, and electrons are move from one electrode to another, obviously towards that anode, toward that positive electrode, and in between, when these electrons collides with helium and the neon atoms, then the energy is transferred from electrons to helium and neon, and then this helium and neon transfer from one energy level to another energy level. So the pumping process is simple. So this pumping process is mainly because of collision of that elastic collision of electron with that helium and neon atoms. So this is the four level system. This is the ground state of helium and this is the ground state of neon. After collision with electrons and other ions, that helium absorbs energy and excite up to higher energy level F2 and F3. Since the helium is 10 times more than neon, so the probability of collision with helium is obviously more in this case, and also this helium, this is lighter than neon. So first, initially, that helium excites up to higher energy level F2 and F3, and after some time the neon atoms also get excited up to higher energy level, that is E4 and E6. So here these energy levels of helium atoms and energy levels of neon atoms are not much different. So that helium, there is one collision that is known as the elastic type collision takes place in between the helium atom and neon atoms. So that energy transfer is occurred from that helium atom to neon atoms. So now neon atoms are extremely excited and ready to give laser. So just I am repeating that process again. So there are helium atoms are here, neon atoms are here at the ground state initially. After collision with electrons, the helium atoms excite up to higher energy level F2 and F3 first, because it is 10 times more than neon, as well as it is lighter than neon. So obviously this will just excite first to higher energy level, and after some time neon atoms also excite up to higher energy level E3 and E4 and E6. Then the energy of this at higher energy level and energy at this higher energy level of neon, these are not much difference. So here this there is a probability of collision of helium atoms to neon atoms, and through that elastic collision the energy of helium atoms are transferred to neon atoms, and now neon atoms are ready to give laser. And after transferring this energy from helium to neon, helium come back to ground state, and again absorbing some energy with the collision with electrons and excite up to higher energy level. So this helium actively participate in the pumping process by absorbing energy from electrons and give energy to the neons. So now neons are ready to give laser, and there are so many different energy levels in between that population inversion condition is fulfilled. One good thing is here, that is in the case of gaseous laser, each and every levels are metastable, because these are the gaseous atoms, so gaseous atoms are not stable, so that's why all energy levels are metastable. So there are several possibilities of population inversion condition fulfilled in between two energy levels. So most probable conditions are here. The population inversion conditions are maintained in between E6 and E3. This is E6 and this is E3. Second, the population inversion condition is maintained in between E6 and E5. This is E6 and E5. And third population inversion condition, that is most probably maintained in between that E4 and E3. So whenever and wherever that population inversion condition maintained, when it gets some photons from Fabry-Perret resonator through a spontaneous process, because there is obviously some probability of spontaneous. So after population inversion condition is maintained in between two energy levels, when external photon is obtained from a spontaneous process, we can get laser. So different lasers of different wavelength we can get in between two different energy levels. So in between E6 and E3 we get 6320 angstrom wavelength laser. This is in the red color. Second, in between E6 and E5, this is E6 and E5, we get another laser that is 3.39, that is 8 micrometer. This is in far IR range. And in between this E4 and E3, we get another laser in the wavelength range 1.15 micrometer. This is in the IR range. And the atoms, that neon atoms, come back to ground state from this E3 level to this E2 level by one spontaneous process, and through which we get 6000 angstrom wavelength laser. And after a de-excitation process by spontaneous collision, these atoms of this E2 energy level come back to ground state, and this cyclic process continues, and we get continuous laser. So this is the mechanism of helium neon laser. And we are using 4-level system. Again, although we have these 6 lines, but we are getting 3 lasers. So these are finally the 4-level system. So advantages: helium neon laser emits a laser light in visible portions of the spectrum, high stability, and it's a low cost, operates without damage at higher temperature. And disadvantages are its low efficiency. Okay, its efficiency is more than that solid state lasers, but still its efficiency is low gain, and helium neon lasers are limited to low power tasks. And the different applications are: helium neon lasers are used in industries. Helium neon lasers can be used in scientific instruments to demonstrate uh, different phenomena related to light. Helium neon lasers are used in college laboratories also to demonstrate that diffraction type experiment. So summary of the lectures. In these lectures, the construction working principle of gaseous laser, that helium neon laser, was discussed in detail. Some limitations and main applications were also discussed at the last. Okay, thank you. Enjoy learning.